So Prefect, what is it? It's a framework for extract, transform, load processes. These are basically any process that takes some data, does some operation on data, and puts it somewhere else. And the framework is written in Python, and it's open source. It implements sort of so-called negative engineering. So positive engineering is that you implement the code that should work and should do something. And negative engineering is all the edge cases that can go wrong. So either the code can have bugs, or you lose internet connection, or your processing machine dies, or anything like that. And covering all these cases is called negative engineering. So basically, these things are all that similar that it's better to use a framework for this than implementing such things yourself. It has a lot of really nice programming patterns and tools for handling problems. And it offers automatization, versioning. It allows teamwork on projects. And yeah, it's really cool. So you might be wondering, is it similar to Apache Airflow? The short answer is yes. Actually, Prefect was created because Apache Airflow wasn't good enough for the new use cases. So they started developing Prefect in 2016. They built on top of on lessons learned on Airflow. So they wrote Prefect in a way that it allows more use cases. It's more configurable, and it's more appropriate for modern development and data science. So a lot of this talk will be a live demo, and I chose sort of real live use case from my work to showcase Prefect functionalities. And the use case is, so we have two images of some bridge. One is from 2016, one is from 2020, and we want to make a workflow that the text changes between these two images, and we'll be using Prefect for this. Okay. So let's start. I actually already prepared all the code for this. I prepared it in steps. We'll be adding things, and I'll be guiding you through this and explaining what is what. So to implement this, in first step, we just implement it without Prefect. For this, I wrote three functions. One is download image, so it gets a bounding box and a time interval. And it will call our Sentinel Hub services to just collect satellite data from the services. The satellite data is from Sentinel to L1C. It's least cloud covered data, so we don't want clouds to detect them. It will be on 10-meter resolution, and this will return an image. So the second function will make some processing on this. So it will take two images, so before and after, and some threshold, and it will do really naive algorithm. So it will take a difference of logarithms of this, or values of these images. It will sum them up over all three channels. It will just take a mask of where the difference is larger than a given threshold. So this mask will tell us which pixels are the one that are sort of different between the images. And then we'll just prepare a sort of visualization image, which will, over these masked pixels, will have these values. So on image, this will, on an RGB image, this will mean that we colored the image with red color on those detected pixels, and it will return this image. Okay, and the third step is saving an image. We'll actually save it on AWS S3 bucket. So first we just fix some visualization on image that it will look nicer. And then we basically use Pillow to save image to bytes.io object, and then pass bytes.io object to Boto3 client to just save it on an AWS bucket. Okay, this is our entire process. And then to run it, so we first download first image from 2015 actually. Then the second image, then we detect change between those two images, and then we save, so detect the change and both images. So let's run this. To take a few seconds. Okay, it's done. Now we can check actually what happened. So let's check the bucket. Something happened. Okay. We have all the three images. We can check the one that we produced. How come? Okay. Zoom in. And we see that we actually detected that this part of the bridge has been built, and actually also something here happened, and there are a few minor pixels detected elsewhere. Okay, so this looks like it's working. Now the question is, what can we do with Prefect? Okay, so now in the first step, we'll transform this into Prefect flow. So on the same code as I've shown before, now I import task and flow objects from Prefect, and I transform these functions into Prefect tasks just by decorating them with task decorator, like this. Everything else stays the same. And then to create a flow, I initialize this change detection flow. And now this process is the same, but since these functions are now Prefect tasks, the flow will recognize them and put them together. So now we can visualize the flow. And we get this nice image. So we can see, okay, we have two downloads. Well, then we save both images, and we also detect change and save that detected change. Okay, so this looks correct. Now let's run it with Prefect. Okay, now the Prefect is showing all these logs so that we know exactly what is happening and which task is being calculated. And it looks like that everything was successful. We can also see on the bucket that images have a new timestamp, so they were saved now. Okay. So far, nothing special. Next thing, what we want to do is, so it's very useful to split parameter values from the code and move them somewhere separate, so that you can change them in that one place and not seek the code for changing any parameter. So we import from Prefect this parameter object, and we put bounding box, time intervals, threshold, and bucket name for parameter. The default values are this. And now this will be a part of the flow. So if we visualize the flow again, okay, now the graph is a bit more complex because the prefect understood all these parameters as initial nodes in the graph. So this is a parameter node, parameter node, parameter node. This one as well, and this one as well. Okay, and we can run it again. Okay, and it worked. So far we've been only just directly running things locally and everything. Now comes really important thing. So the Prefect Server. Now we don't want to run the code in the same environment that we're developing code, but we want to send the code on the server and let the server run it. So how do we do that? So we only have to register the flow. We'll register it with this name, and this will send it to the server. But before we do that, I have to actually start the server. So typically you would have this server deployed somewhere on cloud, and it would be running all the time, but I'll be running it locally. It's done. It actually, what it does is it's using Docker Compose, and it's spawning a few Docker containers with different services, and all this together forms a Prefect Server. To take a few more seconds to set up. And it should be done now, almost. Okay, done. Now I have it here on localhost. Now this is how the Prefect Server looks like. And it will contain all the workflows, all the parameter logs, everything about our work. So to add this workflow, we actually first have to add a project. So at the moment we don't have anything. I'm using the same name as the one that is being used, will be used for registering the flow. Okay. So now we are in the change detection project.
Can you create this project from the command line?
Probably, but so typically you would do this only at the start of the project, and then you would execute a lot of workflows related to this project. So there's probably a way how to do this automatically, but it's a one-time thing. Okay, let's run this. Now we can see that the flow hasn't been actually executed, but it was just pickled and sent to the server. Okay. Now we can check flows, and we have one flow, change detection flow, under this project, and the version is 1. And it turns out that actually if we send the flow to the server again, what happens is, so let's update this. Okay, so now we have the same flow with version 2, and the previous upload, which is version 1, has been archived. So now we can only run the new version of the flow. So this makes sure that we can always run only the latest one. Okay, so now we have some statistics here, like when this has been submitted, by who. We have tasks, runs, schematics, so the same graph that we've seen before, but just visualize a bit differently. Versions, and then we can run this. And now we can see here, those are the parameters that we've set for the tasks, the default ones, but we can change any of this parameter and run with that. So let's run this. Okay, so now it's actually waiting. It won't start running yet. That is because Prefect Server is not in charge of running. It's just in charge of orchestrating and taking care of that things will be passed on, and that everything is saved here. And the entity that is in charge for running is it's called Prefect Agent. So let's start a Prefect Agent. We'll name it Change Detection Agent. Okay, now we have an agent. It already found the flow. It started running it, and now we already see, okay, everything's green, everything has been run. We can see the schematics, everything's green. Gantt chart, so how long each task took, and some logs even. Okay, now this is now much more useful because this agent, so I'm running it again locally, but this agent could run on cloud, and then this agent could actually parallelize execution over multiple workers further and run it on a cluster, and it will be super fast, and everything will have all the information about execution will go back to the Prefect Server and be saved there. Then there's also one thing that you have to be careful about this. So the Prefect Agent has to have the same environment, the same Python environment as your local environment where you submitted the flow, because the flow is pickled and then it has to be unpickled, more or less the same environment. But I guess you can handle this with continuous integration or something like that. That automatically prepares agents to run a certain flow. Okay, next step, we'll add some logging. For example, here in the text change function, we'll count the number of pixels that have been detected as change. So count node 0 on the change mask, and we'll log this. And for this, we just had to take a prefect logger. It could actually also log everything else from the standard Python logger. I think we would have to just add this parameter here to the task to log this. So let's run this version. Okay, we submitted. Okay. Change detection flow. Run. Okay, it's running. It's almost done. Okay, and then we can check logs. And we can see our log. So we detected 274 pixels where some change happened. Okay. The next step, so very important one, is error handling. So let's maybe check this flow. So let's rerun this flow, but we'll change one parameter. For example, let's change this bucket name parameter to something that doesn't exist and run with this. So this now should fail in saving part. Okay, it's failing, it's running. Okay, these all three tasks that were supposed to save something failed. And in logs, we can also see why. No such bucket. Okay, so now we know what happens if something fails, and we could, if execution fails, we can always restart it, and we can make sure that it will only run those parts that that failed. But okay, let's check what are some of the ways of handling failed tasks. So, for example, this download task could fail because for some reason Sentinel-Hub service wouldn't be available for a moment. So we can add here that we'll retry this task 3 times if it fails. And between each of the retries, there will be 10 seconds delay. So this can save us some problems. Then another way is, so when the task finishes, we can configure it that it will save a checkpoint. It will save task result in a local result storage, which will be here. And we can configure it, for example, that it will cache this result for 10 minutes. So this is one way. And there's also another large topic in Prefect, are state handlers. You can basically implement then your own functions which handle state when something happens, and then they can decide what exactly to do afterwards. So for this tutorial, I actually just took an existing function. It's a Slack notifier, and this will notify me on a Slack channel if this function failed. And there are a lot of other integrations with various software. So for example, it could notify me on email, it could save some results anywhere. There are a lot of options. So let's see how this will work. Let's again register this. Okay. Here, close. Okay, let's run it again with false bucket name. It's running. Okay. Now I'm starting to get notifications here. And Prefect actually sent me notification on Slack that something happened, which is pretty convenient if you just run some workflow that takes hours and hours, and you do other stuff in between. Then you can just get such notifications telling you something failed, and you have to check out what happened. Okay, and the last thing out of these basic things is scheduling. So you can schedule runs of the flows, and you can simply do this by taking this schedule object and we'll set it to run on a clock on every 24 hours. And there are a lot of different scheduling objects. You can have all kinds of cron job, all kinds of delays and everything. So yeah, and we put this schedule object here to the flow. And if we submit this schedule, okay, you can see under flows. So here on this graph, we can see that okay, these were my previous runs, And now we have scheduled flows, and we can see that scheduled for 10 days in a row at 1 o'clock. And this will be run. So pretty cool. So, okay, this concludes the live demo. Some additional things to talk about. So Prefect has a huge library of implemented tasks with integration to a lot of different things. So all the cloud providers, email, SQL and databases, Slack, Shell, and a lot of other things, but you can always implement more tasks yourself. Then it's also worth mentioning Prefect Server. So it has actually 6 different components. The UI that we've been looking at. Graphql is very useful, and there are other things. Here is actually a flowchart how this looks like. So we have UI, and we have flows and agents, and this Apollo is the main engine of Prefect Server. We have GraphQL, which is the query language for managing states. This Hasura is sort of an overlying API over Postgre database, and then there's this towel that's sort of maintaining the server. And also thanks to my coworker, Jovan, who prepared this and a few other slides and used them for our internal presentation. Okay. And also worth mentioning is then GraphQL. So this is, as we know, a query language, and it's exposed on a different endpoint. And we can always decide to, instead of looking and clicking in the UI, we can simply run something from the code. We can just connect to the Prefect client and then send queries to GraphQL, which can be also very useful. So to conclude, so we've started using Prefect recently. So far, we've been using it more mainly for experimental purposes or independently, but we're still figuring things out. So I noticed that getting started is actually pretty easy because there are very nice tutorials available for Prefect. But then when you move to advanced things like deploying the server on the cloud and then parallelizing over clusters and maybe running jobs on Kubernetes and such things, then it gets really complicated, and there are a lot of configurations and not that much information online yet, such as Stack Overflow, because this is reasonably new thing. But Prefect has a very active Slack group, so you can go there and actually ask Prefect developers about things. And overall, I think it's a high quality framework. The reason is also that it's business driven. The Prefect is actually a company that's developing this, and then they earn money on providing this advanced usage service. So they deploy your Prefect server on cloud, and they make sure everything is running and that all your use cases are covered. So that's a subscription-based usage, but you can, of course, use it also for free on your own infrastructure. And yeah, we have still a lot of to learn about this. And I'm wondering if someone else has some experience with Prefect, and it would be great if you could share this. So that's all. Let me know if you have any questions.
Thank you, Matej.